When a Linux system is acting strange, the most stressful feeling for a beginner is not the error itself, but the sense that there are too many moving parts to know where to start. Services might not be running, they might be running but not working, or they might be restarting in a loop while everything else seems fine. The reason systemd feels so central in these moments is that it sits in the middle of service management, startup policy, and the record of what happened when something failed. The fastest way to reduce that stress is to adopt a troubleshooting mindset that is consistent, calm, and repeatable, because you will see the same kinds of service failures again and again. In this episode, we focus on systemctl as the interface that helps you ask the right questions, using concepts like status, logs, daemon-reload, enable behavior, and mask patterns. You are not learning a typing routine here, because the exam is testing your reasoning more than your muscle memory, but you are learning how to think like someone who can triage service issues without panicking. Once you know the sequence of questions to ask, the system starts to feel like it is giving you clues rather than random punishment. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first mental step in troubleshooting is to define what problem you are solving, because service problems often get described in vague human terms. Someone might say the website is down, the machine is slow, login is broken, or the network is weird, and those symptoms may or may not be directly caused by a system-to-managed service. A good mindset is to translate the complaint into a testable statement, like the service is not running, or the service is running but not responding. That translation matters because systemctl can answer questions about whether the service is active and what systemd thinks is happening, but it cannot magically fix a network route or a bad DNS setting by itself. This is where status becomes your anchor concept, because status is a way of asking, what is the current truth of this unit according to the system? If you treat status as the start of your investigation, you reduce the temptation to guess and restart things blindly. A beginner who learns to pause, check status, and interpret the result is already building professional instincts. Status information is valuable because it usually combines several clues into one place, and each clue points in a different direction. One clue is whether the unit is active, which tells you if systemd considers it running or successfully completed. Another clue is whether it is enabled, which tells you whether the service is meant to start automatically under the system's policy. Another clue is the recent start attempt history, which can tell you whether the service is failing and restarting. The most important beginner habit is to avoid treating active as the same thing as working, because a service can be active but misconfigured, blocked, or failing to do its real job. At the same time, if a service is inactive, you should not immediately assume it is broken, because some services are designed to run on demand or to execute once and exit. The mindset is to interpret status in the context of what the service is supposed to be, and that interpretation is often exactly what Linux Plus questions are probing. Logs are the second anchor concept, because status tells you what systemd thinks right now, while logs tell you what happened leading up to now. A service can fail for many reasons, and the most reliable clues usually live in the messages it produced when it tried to start. Beginners often avoid logs because they look intimidating, but you can approach logs like a narrative rather than a wall of text. You are looking for the moment of failure and the reason it was recorded, not for understanding every line. Systemd-centric troubleshooting often involves consulting the system journal because systemd integrates service output into a centralized log stream. This integration is powerful because it ties service lifecycle events, like start attempts and failures, to timestamped messages in one place. Even without memorizing exact access methods, the key exam-level skill is knowing that logs are the place where misconfigurations, missing files, permission issues, and dependency failures reveal themselves. When you combine status with logs, you move from guessing to evidence-based reasoning. A common pattern you will see is a service that fails immediately and then keeps trying to restart, which can look like the system is busy or unstable. In these cases, status might show a repeated failure pattern, and logs might show the same error repeating, like a missing configuration file or a permission problem. Beginners sometimes respond by restarting the service repeatedly, which feels proactive but often makes the log noisier without changing the cause. A better mindset is to treat restart loops as a sign that the service cannot reach its required prerequisites. Those prerequisites might be a port it needs that is already in use, a directory it needs that has the wrong permissions, or a dependency service that is missing. Systemd's dependency model means a failure can be caused by something else upstream. So your job is to find the first meaningful error in the chain, not the last symptom. Logs help you find that first meaningful error because it is usually recorded when the service attempted to initialize. Once you fix the cause, the restart loop usually disappears on its own. The idea behind daemon-reload is important because beginners often change a service's definition or configuration and then expect systemd to automatically notice. Systemd reads unit definitions and keeps them in memory, which is efficient, but it means that changes to those definitions might not be used until systemd is told to reload its understanding. The concept of daemon-reload is essentially refresh systemd's unit configuration view so it reflects what is on disk now. At exam level, you should connect this to the idea that configuration changes sometimes do not take effect immediately, not because you did something wrong, but because the manager process is still using the old information. This can create a confusing situation where you fix a unit file or change a drop-in setting, but the system keeps behaving as if you did not. Understanding daemon-reload as a synchronization step between files and systemd's memory helps you avoid that confusion. It is also a good reminder that service management is not only about the service itself, but also about the manager that controls it. Enable behavior matters because it answers a different question than start behavior, and mixing those up is one of the classic beginner mistakes. Starting a service addresses the immediate problem, like getting a web server running right now so you can test it. Enabling a service addresses the future, like ensuring the service comes up automatically after a reboot or when the system reaches a particular target. Many troubleshooting scenarios involve someone fixing an issue, seeing the service run, rebooting, and then discovering the issue returned because the service did not start on its own. That experience teaches an important lesson. A working system needs both correct current state and correct persistent policy. From an exam point of view, you should be able to reason about what enablement implies, which is that the system's startup graph includes that service as part of a target or dependency chain. If the goal is reliable operation across reboots, enabling is often part of the solution, while starting is only the immediate test. Keeping those ideas separate in your mind makes service troubleshooting more deliberate and less random. Mask patterns are a more forceful tool in the systemd world, and understanding them helps you interpret some confusing scenarios. Masking a unit is essentially telling systemd, do not allow this unit to be started, even if something else tries to pull it in. This is different from disabling, because disabling removes it from automatic startup policy, but does not necessarily prevent manual starts or dependency-driven starts in all cases. Masking is like placing a hard block in the dependency graph, and it is often used when a service should never run on a given system, either for security reasons or because it conflicts with another component. For a beginner, the most important thing is not to memorize how masking works internally, but to recognize what it implies when troubleshooting. If a service refuses to start and appears blocked in a way that does not match your expectations, it may be masked, which means the issue is not a misconfiguration, it is an intentional prohibition. In exam terms, masking is the concept you reach for when the system is explicitly preventing a unit from running. These concepts come together into a mindset that can be applied in many situations without becoming a rigid checklist. First, confirm the unit you care about and use status-style thinking to ask what systemd believes about it right now. Next, consult logs as a story of what happened during start attempts, and look for the earliest error that explains the failure. Then consider whether the issue is a definition mismatch, meaning systemd is using old unit information, which is where daemon-reload style reasoning becomes relevant. After that, think about policy versus state, meaning whether the service is intended to run automatically, which brings enable behavior into the picture. Finally, if the service seems actively blocked, consider whether a mask pattern or similar restriction is preventing starts by design. This sequence works because it progresses from current facts to historical evidence, to manager synchronization, to policy intent, to deliberate prohibition. A beginner who internalizes that flow will feel much more confident, even when they do not know the exact technical fix immediately. It is also important to avoid some common traps that make service troubleshooting harder than it needs to be. One trap is chasing symptoms without defining the service boundary, like focusing on an application error without checking whether the underlying service is active. Another trap is restarting repeatedly without reading logs, which can hide the root cause under new noise. A third trap is making changes and forgetting that systemd might need to reload its view of unit definitions, leading you to believe your fix did nothing. Another trap is assuming a service should start automatically because it started once, when enablement policy might not be set. Finally, a trap that feels especially unfair is trying to start a service that is masked, because your actions will not succeed until you remove the block, and the logs may make it look like a deeper technical problem. These traps are not signs that you are bad at Linux. They are signs that you are learning a system with explicit separation between state, policy, and control. A calm mindset treats each trap as a reminder to return to evidence and intent. To close, systemctl troubleshooting at exam level is really about adopting a clear way of thinking rather than memorizing a command sequence. Status is your snapshot of what systemd believes right now, including whether a unit is active and whether it is enabled as part of the system's policy. Logs are your narrative of what went wrong, often revealing missing files, permission errors, dependency failures, or configuration mistakes. Daemon-reload represents the idea that the manager may need to refresh its understanding when unit definitions change, so your fixes are actually seen. Enable behavior reminds you that a service can be working now but still fail after reboot if policy is not set for automatic start. Mask patterns remind you that some failures are intentional blocks, not technical accidents, and recognizing that can save a lot of wasted effort. When you combine these ideas into a steady investigation flow, you move from random restarts to evidence-based diagnosis, which is exactly the kind of skill Linux Plus is trying to measure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit daemon-reload.com.